Yeah. Okay. Okay. Good afternoon, everybody. As you can see, there are a lot of students, and because of that, I had to cancel the previous session. Okay, but we will have another session starting from 2 to 3 at Arundel 401. Basically, a lecture theater on top of the Arundel building. Okay. Today, because I believe that Ian yesterday gave this basic introduction of the module, you'll have many lecturers giving different topics, and in this case, I'm responsible for this first one, that is basically novel advances in connected vehicle networks. Then I will also talk, because this will be a brief introduction about the topic, in this case, connected vehicle networks. Then I will also talk about computing paradigms, cybersecurity, and artificial intelligence. So basically, I'll give you an overview of the research that is being done in this area. Okay. For today, or just for this seminar, the goal is for us to talk about, or at least for me to introduce you first motivation of, okay, why are connected vehicle networks important? Okay, because we have many vehicles, and the idea here is, because we're talking about a network, then we need to see how they can communicate among themselves, okay? Which type of technologies can be used to achieve that, and then, of course, I will go over all those, because what happens is that we have this idea of finding a suitable way, in this case, to avoid problems such as congestion. In this case, or at least to disseminate also warnings. This has come a long way. Then I will show you here how exactly these, when they started, and how all those technologies until we arrive with the most recent one. Okay, then here we'll talk about computing paradigms in this case. Okay, and I believe that you are all aware of at least one of these computing paradigms in this case, cloud computing. Okay, I believe that you are all aware of that, or even fog and edge computing. Or nowadays, because of 5G, most of you may have heard of mobile edge computing. Okay, and how these paradigms are exactly applied in connected vehicle networks. Okay, then because there are always attackers in this case trying to gain some advantage of these networks, then I will talk about the cybersecurity issues and what has been done up until now. Okay, and of course here I will also briefly mention blockchain. I believe that you're all aware of blockchain, right? Okay, and then other hot topic in this case is artificial intelligence, and how artificial intelligence has been applied in connected vehicle networks. And then later I will give some future directions, where I briefly talk about 6G, okay? Because now everyone is talking about 5G, but of course researchers in industry are already, because there has been some deployment of 5G networks throughout the world, and we are now focusing on 6G. Okay. Okay. What's the problem here? Is that when we're talking about connected vehicle networks, we are thinking of how exactly we can apply these networks in order, because the goal here for the economy, in this case, to operate appropriately, then we need to find ways of, in this case, transporting people and goods. For instance, you are doing your masters here, right? But some of you are not even from, in this case, you weren't born here in the UK, or are living here in Europe, okay, you came from many parts of the world. We have a vehicle, in this case, an airplane that actually took you from your home location into here. Then, once you arrived here, then you need also to find ways to move from where you are living. Of course, I'm not considering the ones that are actually living here on campus, okay? Some of you may be living where? In Brighton or somewhere else, okay? And of course, there is another problem in this case is that once, if in this case, if you need to move from your location and depending on the hour that you want to move, if you can grab a chair and come here, okay? Okay? If in this case you need to move from where you are, you need to grab the chair. From where you are to university, and depending on the hour, because of the rush hour phenomenon, what will happen is that you may, depending on which time you get out of your house, you may arrive here late. Because many are trying also to go to work. Okay? That's why, and of course there is another issue, very important issue in this case, is that we are always trying to reduce fatalities in teachers. You can have an example of the United States. As you can see, this is let me see one here. Okay? And imagine the amount of injuries. 5.4 million injuries. And of course, the other problem is how much they spend because of this. Almost 500 billion. Okay? And the other issue here is that because of traffic jams, there is a lot of hours, in this case, a lot of time that we are actually wasting. Just imagine, for instance, that you want to get from Brighton to London. How many of you have tried renting a car and going to London? You tried, right? How many hours?
Took me about like,
Sorry?
took me about like half a day to get there. I went on a match, there was a match happening, and it was traffic.
Yeah.
Just stopped.
Match day, another problem, okay? At least 2 hours from here to the center of London on cars, okay? It's a lot of time, okay? And of course, we are considering here time, but there is also the problem because if you have a car, then we need to pay for gas, okay? And of course, where there is opportunity, then many will try to profit from it. If somehow you can, for instance, start offering services, for instance, imagine what happens with, some of these are already available. For instance, even Google tries to offer this type of services. If you, for instance, based on your daily patterns, if you move at a given time from home to office and then from office to home, then closer to that hour, they will send you more or less some information, give you some sort of an estimate of how long it will take for you to commute from one place into another. Okay? What's actually happening here is that around 99, okay, FCC, this is the Federal Research Commission, allocated the 5.9 gigahertz, okay, band to promote safe and efficient highway applications. Because the idea in this case is to try to avoid, at least to reduce this, okay, and of course, easier because it has a lot of influence in society, okay? And because here we have two main types of communication. You may have, or at least the applications we're targeting, communication among vehicles and between vehicles and infrastructure, in this case, okay? Because you may have to collect, for instance, some information and then send to some sort of a central processing unit so that they can do additional so that they can, based on this information that you are actually providing, they can extract more useful information, in this case, to apply for instance, to reduce traffic congestions or any of these other problems. And the other, because here we're talking about communication among vehicles, in this case, we are talking about Wi-Fi, okay? But there is, of course, a different, because most, when we're talking about Wi-Fi, we are talking about 802.11. In this case, what we're talking about vehicular communication, we're talking about 802.11p, okay? And this is, of course, also known as DSRC. That stands for Dedicated Short Range Communication. Security, as you will see, is also a problem, okay? And when we are designing a product or we want to sell something, okay, we should also take into account security, in this case, aspects, okay? As we're talking, still motivating this problem, in this case, we have here what kind of services can, for instance, connect the vehicle networks actually provide. We have here congestion detection. In this case, it would be quite good if you want to, in this case, simple, travel from here to, or you are, for instance, in holidays, or even if you want to commute to work, it would be quite good. Or if, depending now, we are heading into winter and rainy season, and for instance, depending on where you are living, you may have some floods, okay? And because of that, some roads may be actually, you won't be able to use some of these roads. Then, in this case, for instance, receiving notifications about congestion pathways or congestion paths that are happening in some given locations, or even, for instance, enabling platooning applications. Because the good thing here is, when we're talking about platooning, is that you have, for instance, some vehicles that are actually heading in a coordinated manner towards a given location. Okay, that is good because you can actually reduce fuel consumptions and other aerodynamic issues. Okay, then we have also here road hazard warning. Okay, and we actually see some images about this. Another interesting application is this collision alert. If someone, for instance, if you're just heading and someone, for instance, we're in some sort of an intersection, okay, and there is some sort of a stop signal, okay, and we are heading into that. If this guy here doesn't stop because he can't see us, what will happen is that then we will have a bit of collision. And for instance, there is also another application, in this case, is the tool collection. Okay. Let's see here some examples. Okay. In this case, we have suppression, and this guy is notified, okay, because this vehicle is stopped, and then you will have, in this case, to reduce the speed in order to change to another line. And we have, in this case, this is one example that I've actually mentioned before. We have here this sort of a collision warning that's actually informing this vehicle that he needs to stop because this other one is actually also heading in this way. Okay. Then we have here also deceleration warning, okay? Because this guy here, or at least these guys here, need to be informed that this car is actually decelerating. And we have, we're talking about traffic and road conditions. Is proper image. Okay? Imagine that you need to go to work. Imagine that you need to go to work and you are, for some reason, stuck somewhere here. Okay? And we have another one. Okay? It's freezing outside, and because of the weather, you can actually move. You have your two options. Okay? If you switch your engine off, what will happen? You'll start freezing. And if you keep it running, and depending on how many hours this will last, what will happen is gradually you will start emptying or using your gas. Okay, okay, decisions. Okay, and we have, of course, another situation in this case. This the yellow vehicle actually lost control of his car, or the yellow driver in this yellow vehicle lost control of his car, and in this case we have here a collision, because in this case what would be good is to send a notification to emergency service so that they can actually dispatch some sort of an ambulance to come and assist in this type of events. Right? You at least now know what are possible applications, okay, for this. Now what we need to know is how exactly can we put two vehicles, or which technologies actually enable these vehicles to communicate. In this case, we already mentioned, for instance, DSRC, in this case, IEEE 802.11p, okay? You already know that because this one enables vehicle-to-vehicle and vehicle-to-infrastructure communication. But nowadays, because of 5G, what we have something that is called CV2X, in this case, cellular vehicle to everything, okay? And these communication technologies, according to the ones actually proposed, and as you can see here, aims to revolutionize everything. And we will also discuss a little bit of this, because now we'll just compare these two technologies. Okay? And the good thing here is that both are operating at 5.9 GHz. Okay, let's start with the first one. 802.11p belongs to this family of standards, in this case, is 1609. Okay, and we're talking about 1609, and if you remember, we're talking about enabling communication between, in this case, stations and stations to response, in this case. I'm referring to enable communication between vehicles and vehicles vehicles, in this case, to structure. Okay, and as I have been telling you, the goal here is to promote, or in this case, to save lives and to promote safety and fluidity in transit. Okay. There are some similarities between a well-known, in this case, a well-known standard, in this case, that is the IEEE 802.11a. Are you aware of the .11a? Yes or no? No. Wi-Fi. You never set up 11.a? How many of you have played with an access point? Huh. Should play. Let's start like this. Okay, at home, do you have a router or no? Yeah. You have, right? Yeah. You never played with that. It's like you just want the password and connected and everything. Play with it. You don't need to. Just try getting it and see what are the options. Okay? Don't worry. You won't mess it. Or even if that happens, then you call for support and they will fix it. Okay? It's easy. You should play with this stuff. Okay? What happens here is that the 802.11a and .11p are actually similar. Okay? And difference is mainly related with the bandwidth, and of course, it is mainly related with the bandwidth. That one is the double of the other. Okay? And because this can be seen as something good, okay? Because when we're talking about this standard here, as you can see, this was or this 802.11p was standardized around 2004, and now we are 2023, almost 20 years ago. This means that some work has actually been done, and because this has been around for quite some time, and of course we have the wireless access in vehicular environment standard that's actually used. And we have this image here that shows, for instance, we're talking about 6 and 09. What you can see here, we have the MAC layer, okay? These are mainly lower layers, okay? And then what we have here, we have then another set of layers that in this case, we have a non-IP, and this is basically the IPv6 stack. Okay, in this case, this actually enables both non-IP and in this case IP stack. And then we have here at higher layers, we have a set of applications. We are talking about here BSM messages. Okay, BSM stands for basic safety messages, or in this case, traffic fee collection. Okay, these are interesting applications that we are going actually to see here. Because when you're talking about the first one in this case, it's mainly because this can enable the collection of fees. Because while you are going over some sort of a tool guide, then it could automatically collect. In this case, you should automatically be paying for. And then we have also this. That's actually another very important application, because if you have this big network, the idea is for the vehicles to exchange information. Okay. In this case, we're talking about BSM messages, okay? They're basically some sort of message just saying, okay, I'm here, and everybody's saying where they are. And based on this, if you know where all these vehicles are, then you can start, if you want to send information, for instance, something happened, okay? Then you can, in this case, send information, or if some sort of an accident happens somewhere, then all these vehicles can actually start contributing to forward this information to some sort of an emergency unit. Then we have 5G. Okay? When we're talking about 5G, we need to talk about these two standardization bodies. In this case, METIS and ATU. Okay? Because, and this, of course, is a little bit, what happened here was that this actually is what they are now doing with 6G, is that these guys just sit and decide, okay, we now have 4G, right? But we want to enable more applications. What we need to do? Okay, let's think of, for instance, the next technology, okay, will enable, in this case, speeds higher than 1 gigabit per second. Because for 5G, what they were aiming is for you to have speeds between 100 megabit per second and 1 gigabit per second. Okay? And literally, you have, how many of you have tried using 5G, just doing a test to know which speed your network allows? How many of you? What was the maximum speed that you got? 800. Right, quite good. Any others? 650. Look. That's very nice. That's very good. I almost got around 500. Oh. Good. Operators. Okay? What happens here is that, as this image shows, okay, we want for all these objects that you see here, in this case, including pedestrians, to be able to communicate among themselves. Okay? Because by sharing all this information, then if all this collected data is sent for further processing, then we will be able to do fantastic things. Okay? And this, of course, is 5G allows. Okay? There are many advantages when you're talking about 5G. Okay? We have, for instance, millimeter wave. Okay? In this case, in the goal of millimeter wave, we're talking about high throughput and bandwidth. Okay? In this case, you want to send or at least download content at higher speeds. In this case, we have NOMA. In this case, it's basically to enable us, depending on where you are, to cancel interference. Okay? Because if you have many devices trying to send information, then you need to find ways of sending, or at least enable them to sharing time or even frequency resources. Basically, these are scheduling policies in order to enable them, everybody to start to send information. Okay. Then what we have also multi-RADS, in this case, multi-radio access technology that enables, we're talking about even for V2V, and in this case, or V2I and V2N, this enables to increase network capacity and throughput. Then we have another thing that's actually antenna design, because even by properly designing antennas, you can actually increase the capacity of the system. And we have also in-band full duplex in this case, that as you can see here, we have that millimeter wave enabled to increase throughput, and also the goal of in-band full duplex is the same. And then what we have in this case lastly is mobile edge computing. By using mobile edge computing is what we mean by mobile edge computing. You have base stations. Are you aware of what are base stations?
It's like a data center, so like centralized space for connection.
Mobile operator space station.
So where those towers connect to one station, and those towers connect to the user.
What happens here is that your phones are connected to a base station. Okay? There are base stations throughout UK, throughout the world. Every time that you are in a given location, your mobile phones, in order when you see their signal, okay, you need to see how far you are from a given base station. Okay? When you move, it will by the handover, okay, it will basically change to another base station. What is the factor here? The distance until that specific base station. If you're talking on your phone, okay, because you have many of these base stations, there is something that's called handover that happens. In this case, basically changing. Okay, they need to pass all those resources associated with this call into another base station. That's why you can talk while you are, for instance, moving on the train or even on the car. Okay? Yes, but what happens here when we're talking about base stations is that when for instance, 4G, 3G, and below, they're like normal. They just added, for instance, they enabled, by using different technology, they increase the speed at which you could download data. With mobile edge computing, you could do more. Why? Because then they added servers to base stations, okay? By adding servers, then you have computing power. And what's the advantage? Normally what happens is that you need to send, for instance, or some of these applications would need to send data to the cloud, okay? You're connecting to the cloud, you have your mobile phone, you have your base station, and then you send this information, you use the base station to send this information to the internet, okay? What happens is that if you have computing power at the base station, then you don't need to send this information to the cloud. Some processing could be done at the base station, okay? What happens, this actually reduces delay, okay? This is just a comparison between 5G and wave in this case, and as you can see here, we have many interesting technologies. The goal here is to increase throughput and, of course, to reduce latency. Okay, and we have here, as you can see, this was standardized around 2004. Okay, in this case, by being a more consolidated technology, low latency, and because we are talking about web, this communication between vehicles, we don't need actually infrastructure. In this case, infrastructure is actually not necessary for vehicles to communicate among themselves. Okay, but okay, the challenge here is that, okay, 19 years passed, Okay? How many of you have heard of vehicular networks before this lecture? 2, right? And how many? Like, okay? Most don't know that this technology exists. But now 5G, how many? Everybody knows about 5G, right? Okay? Or even most of this technology. That's why we are a little bit reluctant if this will be actually adopted by many nations, okay? And of course, here the main problem is related to this thing here. If I remember correctly, China was quite far ahead and developed in the development of 5G technology. Okay? Because of that, they had a lot of plans. The rest of the world needed to catch up with that. Okay? But of course, this will always happen. Okay? Why? Because profit. Don't forget that. Okay. Let's see. When all of this started? This started almost, as you can see here, this was around 1994. We had the first Congress related to ITS. Okay? And this development started actually quite a long time ago. As you can see here, since the introduction of the first traffic light, today that we have a lot of devices and sensors. We have cameras and many devices on roads. Okay, and what happens here was that the first thing that was actually proposed was intelligent transportation system. In this case, it can be defined as an advanced information communication and electronic technology system that unites users, highways, and means of transportation in order to increase safety, convenience, efficiency, logistics, and the productivity of any process involving the transportation of people and goods. As you can see here, many started working on improving a lot of things that we have here. And in addition to that, as you can see, we want to transport people and goods, okay, because only by doing that is that the world economy will actually continue to improve, but we need at the same time to reduce, okay, the pollution. It's good, right? Fly. Catch an airplane and go from one place into the other. You know how many airplanes are traveling right now? A lot, right? A lot of pollution is already on the air. And if we add the pollution that we have here also, what most of the times we just don't care about that. Okay, but there's a lot of pollution happening actually, and we have also at sea. Okay, because most cargo is actually transported by sea. It's not by plane. It's by sea. Okay. This image here just illustrates what we want to achieve. It's basically every one of these objects to be able to communicate among themselves. Then, because we were talking about ITS, the first approach in this case, what we want is for everybody, or what one of the goals was for everybody to be able to do simple things such as set up a journey. In this case, I want to, in my car, okay, what I want to do, I want to travel from here to Birmingham, for example. Okay, these everybody should be able to do. Then, okay, we had this fantastic thing that is called vehicular network vehicles. Here now we are talking that we want, besides what we have seen, we want vehicles to be able to communicate among themselves. Okay, and in this case also to use vehicle to infrastructure. When we add these two, we have something that's called the vehicular networks. And the goals for this type of network is in this case is to optimize traffic and reduce also emissions. Okay. In terms of the system model, what we have here, we have users in this case, because if you have cars, we need to have the ones that actually are driving those cars or at least own them. We need to have also network users, in this case network nodes, okay? Because if we want to, depending on the application that you want to enable in this type of networks, then some nodes may need to have some sort of processing capability, okay? And then we have another very important element in this case, that is the trusted authority. Why is the trusted authority important? If you have a network, you need to have someone at least checking who belongs to your network. You need to enable, in this case, nodes into your network and then be able to exclude them. Okay, that's why this trusted authority is actually very important. The problem, okay, as you have seen, it added some very interesting things, but the problem of neural networks is that they are not able to analyze, process, or even evaluate this information that's collected. Not just exchange information, okay? That's good, okay? You can be aware that something is happening, but some other added value services and applications are not possible, okay? That's why later on it was proposed the Internet of Vehicles, okay? And when we're talking about the Internet of Vehicles, okay, in this case we are talking about a network of the future, okay? Why? Because this enables the integration between devices, vehicles, and users in some sort of an unlimited and universal manner, and therefore overcoming also the heterogeneity of systems, services, applications, and devices. Now we can start talking about intelligence. Why? Because by means of Internet of Vehicles, then you can start using this information to do something more. You collect information, and because now you have artificial intelligence, then you can start doing something more. In this case, such as predicting congestion, and all those very nice applications. There are many or some architectures, IOV architectures, but I here will only present you, okay? The 5 and 7 layers. Let me know if you have questions, okay? You can just raise your hand. And, okay. When we're talking about the 5-layer architecture, what we have here? We have where data is collected, how or which technology we're going to use to send this data. In this case, if you are talking about Wave or 5G, then we have a way to do something more with this data. Okay? And of course, we have other layers. In this case, for instance, such as this one here, the business, to add commercial value, okay? Profit to what you are, to the application that you are actually designing. And then this is closer to the previous one, but we have here additional layers, and one of those, as you can see here, we have security. Okay? And security is actually, as I mentioned, very important, and as we will see this week, we will talk about also about security. Okay, what are the challenges here? How many manufacturers do you know? Vehicle manufacturers, car manufacturers, how many?
10.
Sorry? Can you start listing some? Volkswagen, Audi, Ford, sorry, Delta, what? Tesla, yes. Hyundai,
Ford, Tata,
Tata,
Genesis.
Genesis. Look, you know a lot of. As you can see, you have many manufacturers. What do you think? Do they all talk to themselves or very well regarding equipment? Do they share their technology? No, right? This brings a problem that's related with heterogeneity. Okay? If you have many players, each one is actually developing his own technology, then you may have problems with heterogeneity. Okay? And then the other one is related to scalability. Do you remember that image that I've shown regarding traffic jam? I think it was in India, right? You remember?
Yeah.
Yes. What's the issue here? If you have there is a difference in having 1,000 cars and 10,000 cars closer to each other, okay? Or even 10 cars. Why? Because of scalability. You can, for instance, how many have you developed web applications? So, okay. Imagine, for instance, a website, okay, or online site such as Amazon. I believe that most of you know Amazon, right? Yeah. Great. There is a sale, and 50% of you want that specific product, and it will start at 2 p.m. What will happen? Not really. Nowadays, no. With Amazon, no. Why? We'll see when we talk about competing paradigms. You will have, normally, if it was something different from Amazon, or at least your own web application, okay, what would happen is that you would have a crash. Right? Yes. But because they use something they use competing paradigms, and therefore, if it crashes, then something really went wrong. Okay?
Is it using load balancers then?
Also. Okay. Then we have security. Okay? Because if you forget security, then you will have problems. Why? There are smart guys that will try to steal your information and then sell it yourself. Hey, or I will disclose this information. Then you have also quality of service, because if you have customers, you want for them to have a good experience. Okay? And you have also cooperation. Okay? Because if you have many nodes, you want them to be able to work together on themselves. Okay? What I will do before we start this one, let's move to the other room. Okay? We'll have 10 minutes and we can start a little bit early. Okay? Okay.
Sorry, sir.
Yes.
I want to share something for you. Last year, I worked in